How do we find general solutions of trigonometric equations? To write a general solution means to include all of the coterminal solutions. So if we have that pi is a solution to a particular equation, then that would include pi. But if we went around another 360 degrees, or 2 pi, that would include 2 pi plus pi is 3 pi, or 5 pi. So this solution, this way of writing it, gives us the original solution plus any multiple of 2 pi. So pi, 3 pi, 5 pi, 7 pi. It also includes negative values. So if we said n was -1, we'd get negative pi, negative 3 pi, etc. So if we are asked to give all the solutions to these equations, this is a very sloppy unit circle. We have sine of theta equals -1. That's at 3 pi over 2. So if we take 3 pi over 2 and add 2 pi n to it, we can find out that those are all of the coterminal solutions. If we have tangent of theta equals 1, we can say that the slope of that line is going to be 1. So because of that, we have two original solutions. One of our solutions is here at pi over 4. The other solution is at 5 pi over 4. So we can say that this is pi over 4 plus 2 pi n, and 5 pi over 4 plus 2 pi n. So I would accept this as our general solutions. But in this particular case, we have an even easier answer. Because these solutions are pi apart from each other, instead of saying 2 pi n, we can say that they're all pi over 4 plus pi n. Because if pi is 1, then we'd get 5 pi over 4. So this would be the better way to write the answer, because this particular case has two solutions that are equidistant on the unit circle. But generally, we're going to be just writing our one or two solutions with plus 2 pi n after it. Here we have cosine is 1/2. So that would be, we have pi over 3 and negative pi over 3 as our original solutions. So we can say pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n as our general solutions. This last one is kind of trickier. We have sine of -3 theta equals 1. So that's telling us that 3 theta equals 90 degrees, or pi over 2. So this -3 theta equals pi over 2 plus some 2 pi n. Now it's important to add this 2 pi n before we solve for theta, because we want to say that it could be pi over 2, or it could be 5 pi over 2, or it could be, what would that be, 9 pi over 2. Anytime that we add 2 pi to this angle, the angle that we're taking the sine of, we're not taking the sine of theta, we're taking the sine of -3 theta. So that we add the 2 pi n before we set it equal to the input. Now we can solve by dividing by -3. That's really sloppy handwriting. Divide by -3 on both sides. So theta equals negative pi over 6 minus 2/3 pi n. So these are our general solutions for this equation, negative pi over 6 minus 2/3 pi n. In other words, find your solutions normally, and then at the point where you're essentially doing the inverse sine, or inverse cosine, or inverse tangent, or whatever you're doing, then add 2 pi n before you solve.